Good afternoon, everyone, and welcome back. Right now, at the moment this video is being recorded on March 17th, 2026, we are witnessing something that happens extremely rarely in the history of astronomy. Within about an hour of this recording, the third confirmed interstellar visitor ever detected, known as 3I, Atlas, will reach its closest approach to Jupiter. The distance is about 53.6 million kilometers, which may sound large, but in astronomical terms it is incredibly close. In fact, it is essentially brushing the outer edge of Jupiter's Hill sphere, the boundary where Jupiter's gravity begins to dominate over the gravity of the Sun. That location in space is extremely important, and later in this video we'll talk about why that particular region matters so much. But first, let's step back and remember how this strange story began. The object was first detected in July of 2025 by the Atlas survey, and from the moment astronomers realized it was not bound to our solar system, it immediately captured global attention. It quickly became clear that this object had come from interstellar space, meaning it originated somewhere far beyond our Sun. Since its discovery, 3I, Atlas has traveled on an incredible journey through our solar system. It passed near Mars, then continued past the Sun, moved through the inner solar system near Earth, and is now approaching a close interaction with Jupiter, the largest planet in our system. After that encounter, it will leave the solar system entirely, escaping back into interstellar space at a velocity of roughly 66 kilometers per second. So why is this moment so important? Why are astronomers paying such close attention to this object? The reason is simple. 3I, Atlas, is not behaving like an ordinary comet. Recently, Harvard astrophysicist Avi Loeb published an article with a striking title, 3I, Atlas is fading away. In that work, he identified 22 separate anomalies associated with this object. 22 different features that do not fit comfortably with our current understanding of natural comets or interstellar debris. In this video, we are going to carefully examine every one of those 22 anomalies. And by the end, I will also add 2 additional anomalies of my own, bringing the total number to 24 unusual characteristics connected to this object. Now, when this story first began, I assumed 3I, Atlas, was simply a normal comet that happened to be traveling unusually fast because it originated outside our solar system. At first glance, it looked like just another icy body passing through on a long cosmic journey. But as more observations came in, the situation changed dramatically. What initially appeared ordinary has slowly transformed into one of the strangest astronomical objects ever observed. So we're going to start by looking at the earliest anomalies scientists noticed, and then we'll gradually move into the more bizarre ones. Although, to be honest, almost every single feature of this object is unusual in one way or another. And remember, we have 22 anomalies to examine, plus 2 more at the end that may be just as scientifically significant. Let's begin with the first anomaly that Avi Loeb highlights, something known as the mass-budget discrepancy. The nucleus of 3I, Atlas, is estimated to be about 2.6 kilometers wide, and its mass is believed to be around 1 billion tons. That is extremely large for an interstellar object, and even quite large compared with many ordinary comets inside our own solar system. But the real problem is not simply the size. The real issue is where such an object could have come from. Astronomers believe that 3I, Atlas, likely originated from an old star system with very low metallicity, meaning it formed in an environment that did not contain large amounts of heavy elements. In regions like that, objects of this size should be extremely rare. According to our current models, if something this large were common, we should have already observed hundreds of smaller interstellar objects passing through the solar system long before discovering one this massive. Objects similar in size to Oumuamua or 2I Borisov should have appeared far more frequently. Instead, what we see is the opposite. A massive object arrives first, which statistically makes very little sense. The probability that something this large would randomly pass through our solar system without us seeing many smaller ones beforehand is incredibly low. That leads directly into the next anomaly, which involves the geometry of the object's trajectory. 3. I, Atlas, is traveling on a retrograde orbit, meaning it moves in the opposite direction of the planets, around the Sunday, but what makes this strange is that its path aligns within about 5 degrees of the solar system's orbital plane. Most comets, especially interstellar ones, enter from completely random directions. They usually cross the solar system at steep angles that have nothing to do with the plane in which the planets orbit, but this object entered almost perfectly aligned with that plane, and that alignment makes it extremely convenient if an object were to pass close to multiple planets in sequence. The odds of that happening purely by chance are estimated to be around 2%. Then there is anomaly number 3, which has to do with timing. The arrival of this object appears almost unbelievably precise. During its journey through the solar system, it passed within 29 million kilometers of Mars, then moved toward Jupiter, where it is now approaching within 54 million kilometers, and it also passed less than 1 astronomical unit from Venus. What makes this particularly strange is that at the exact moment it reached perihelion, its closest approach to the Sun, the object was temporarily unobservable from Earth. Avi Loeb describes this as a fine-tuned arrival, a trajectory that seems unusually well aligned with several planetary encounters. And this leads directly to anomaly number 4. Today's close approach to Jupiter, known as the Perijove distance, is about 53.6 million kilometers. That distance places the object astonishingly close to the boundary of Jupiter's Hill sphere. In fact, it is only about 100,000 kilometers away from that critical gravitational boundary. In cosmic terms, that is an incredibly precise alignment. Some researchers have even suggested that if an object wanted to deploy probes that could remain gravitationally bound to Jupiter, this location would be almost perfect for doing exactly that. But the trajectory anomalies are only the beginning, because once astronomers began studying the jet system of 3I, Atlas, things became far stranger than anyone expected. The behavior of the jets coming from 3I, Atlas, is where the situation begins to look truly unusual. In an ordinary comet, jets form because sunlight hits the surface, causing frozen gases to sublimate and erupt outward. These gas plumes usually point away from the sun, pushed by solar radiation and the solar wind. But with 3I, Atlas, the observations are very different. Anomaly number 5 involves a prominent anti-tail, a jet that appears to point toward the sun rather than away from it. This feature was observed both before and after perihelion and extended for distances between 500,000 and 1 million kilometers. Instead of being pushed away by the solar wind, the structure seemed to resist it completely. Even more puzzling, its direction flipped perfectly before and after perihelion while still maintaining a sunward orientation. Then comes anomaly number 6. This antitail is extremely collimated, meaning it is tightly focused. It is about 10 times longer than it is wide, and it maintains its direction over hundreds of thousands of kilometers. Normally, if a comet is rotating, its jets spread out or fan across space as the nucleus turns. But that does not appear to be happening here. Despite the expected rotation of the object, the jet remains almost perfectly aligned. Anomaly number 7 introduces another surprising observation. In addition to the main antitail, astronomers detected 3 smaller jets emerging from the object. Even more unusual, these jets appear to be symmetrically spaced at roughly 1-2-0 degree intervals around the body. In a natural comet, gas vents appear randomly across the surface depending on where ice deposits are exposed to sunlight. Symmetrical spacing like this is extremely uncommon. Then there is anomaly number 8, which involves a wobble in the perihelion jet. By itself, a wobble might not be especially surprising. Rotating bodies often produce slight changes in jet direction. But when scientists examined the data more closely, they discovered something even stranger. Anomaly number 9 shows that this wobble switched perfectly from the night side of the object to the day side after perihelion. In other words, the orientation of the object relative to the sun seemed to flip in a way that maintained the same directional alignment of the jets. The poles of the object appeared to keep pointing in essentially the same direction toward the sun, even after the object's orbital position changed. The probability of such a precise alignment occurring randomly is extremely small. Finally, we arrive at another key anomaly involving non-gravitational acceleration, often abbreviated as NGA. Comets frequently experience slight acceleration caused by gas escaping from their surfaces. When gas vents outward, it acts like a small rocket thruster, slightly altering the comet's motion. But in the case of 3I, Atlas, the acceleration pattern does not behave the way astronomers expect. Instead of being pushed mostly away from the sun, about half of the acceleration appears to be directed sideways toward Jupiter. In typical comet behavior, sunlight hits the side facing the sun, and gas escapes in the opposite direction, pushing the comet away from the sun like a launchpad effect. But the motion observed here does not follow that simple pattern, and that raises an obvious question. If sunlight and ordinary sublimation cannot fully explain the motion of this object, then what exactly is driving it? Up to this point, the anomalies we've discussed mostly involve trajectory and geometry. But once astronomers began analyzing the chemical composition of 3I, Atlas, the mystery deepened even further. Anomalies 11 and 12 involve the presence of nickel in the gas plume surrounding the object. Normally, comets contain far more iron than nickel because iron is more common in cosmic material, but in this case, the plume appears to contain significantly more nickel than iron. This has never been observed in a natural comet before. Astronomers have proposed a possible explanation involving something known as the nickel-carbonyl process, which could theoretically produce nickel-rich gas under certain conditions. However, there is a problem with this explanation. That process is known to occur mainly in industrial environments where metals are processed artificially. It has not been observed occurring naturally in space. So if this object formed naturally, it would represent a completely unique chemical environment that we have never encountered before. The chemical puzzles continue when scientists examine the ratio between nickel and hydrogen cyanide in the plume. The ratio detected around 3I, Atlas, is orders of magnitude higher than what we see in known comets. Then there is the water content. Before the object reached perihelion, water made up only about 4% of the total mass, which is extremely low for a comet. Normally, comets are rich in water ice, which is why they produce such strong vapor tails when heated by the sunday. But after perihelion, something strange happened. The amount of water suddenly increased dramatically, rising to levels much closer to what scientists expect from cometary material. Such a sudden shift in water production has not been observed in ordinary comets. Another surprising observation involves the color and brightness of the object. As 3I, Atlas, approached the sun, it brightened rapidly and shifted toward the deep blue spectral color. The temperature of the material appeared to rise dramatically, reaching levels hotter than the sun's outer corona. That is something astronomers have never seen from a normal comet. Then there is the issue of polarization, which refers to the way light scatters off particles in the object's coma. The polarization signature of 3I, Atlas, is extremely unusual and does not match the scattering patterns we observe from typical comet dust. Observations from the ALMA telescope array also detected unusually high levels of methanol in the surrounding cloud of gas. Methanol does appear in some comets, but the concentration here is far higher than expected, especially when compared to the relatively low amount of hydrogen cyanide, and the composition continues to change. Prior to perihelion, astronomers detected icy fragments breaking away from the object, but after the close solar encounter, those fragments disappeared entirely, while the object suddenly began producing 20 times more water vapor than before. This sudden change in composition is extremely difficult to explain using standard comet models. And then there are the isotope ratios, particularly the ratio of deuterium to hydrogen in the water molecules. Deuterium is a heavier form of hydrogen that contains an extra neutron. While small amounts exist in nature, the concentration observed here is far higher than anything previously measured in comets. Which brings us to the final group of anomalies that cannot easily be categorized. Beyond the chemical and physical puzzles, a few additional observations make the story of 3I, Atlas, even more intriguing. One of them involves the direction from which the object entered the solar system. When astronomers traced its incoming trajectory backward through space, they noticed something surprising. The path of 3I, Atlas, aligns within about 9 degrees of the location in the sky where the famous WOW signal originated in 1977. The WOW signal was one of the most powerful and mysterious narrowband radio signals ever detected by the SETI program. It lasted for only a short time and has never been definitively explained. The probability that 3I, Atlas, would enter from nearly the same region of space is estimated at roughly 6%. While that does not prove any connection, it is certainly an interesting coincidence. Another anomaly concerns the purpose of the Sunwarp jet. Avi Loeb suggested that the jet might act as a kind of shield against interstellar dust. Objects traveling through space at extremely high velocities face constant impacts from microscopic dust grains, which can gradually erode their surfaces. A forward-facing jet could potentially create a protective barrier. Finally, there is the issue of the dust particles in the anti-tail. If the tail is made of dust rather than gas, the particles would need to be much larger than typical interstellar grains in order to survive exposure to the solar wind without dispersing. Taken together, these observations bring the total number of unusual features to 22 anomalies, and that alone would already make 3I, Atlas, one of the most mysterious objects astronomers have ever studied. But the story does not end there, because there are 2 additional anomalies that some researchers believe may point to something even more extraordinary. The first additional anomaly involves the deuterium-rich water signature detected within the object. The unusually high ratio of deuterium to hydrogen has led some researchers to speculate about a completely different interpretation. Deuterium is an important ingredient in fusion reactions, which are the same type of nuclear processes that power stars. In theory, a compact fusion reactor could use deuterium as fuel to generate enormous amounts of energy. Some have suggested that the icy fragments observed earlier and the sudden spike in water emission after perihelion might resemble the release of coolant or reaction mass, rather than simple sublimation of ice. In this interpretation, the jets and flares observed around the object would represent controlled exhaust from an energy system rather than natural comet outgassing. The final anomaly builds on that idea and involves a possible magnetohydrodynamic propulsion system, often abbreviated as MHD propulsion. This type of system would use magnetic fields to accelerate ionized plasma, creating thrust without traditional chemical rockets. Interestingly, methanol, the compound, detected in unusually high amounts around 3I, Atlas, could theoretically be ionized and used as reaction mass in such a propulsion system. If plasma were accelerated through magnetic fields, it could explain the extremely narrow and symmetrical jets observed around the object. The sideways acceleration detected earlier could also be interpreted as vectoring of plasma exhaust, while the three evenly spaced mini-jets might function as attitude-control thrusters. In that scenario, the object would contain three key components: deuterium as fusion fuel, methanol as propellant, and metallic elements such as nickel acting within the propulsion system. Now, this interpretation is highly speculative, and many scientists would argue that natural explanations may eventually be found for all of these anomalies. But it does raise a fascinating possibility. Imagine for a moment that the enormous antitail is not simply a strange dust plume. Imagine instead that it is composed of millions of microscopic solar-absorbing machines forming a structure similar to a miniature Dyson swarm. Such a swarm could absorb sunlight and store enormous amounts of energy. If even a fraction of that energy were converted into propulsion, the object could theoretically accelerate to several thousand kilometers per second, approaching a few percent of the speed of light. At that speed, travel between stars could shrink from tens of thousands of years to only a few centuries. And if that were true, then perhaps 3I, Atlas, has not simply been passing through our solar system. Perhaps it has been refueling here. Of course, these ideas remain speculative thought experiments, but they illustrate just how extraordinary this object may be. With 24 anomalies in total, 3I, Atlas challenges many assumptions about what interstellar objects should look like. So now I want to hear from you. What do you think is really happening with this mysterious visitor? Is it simply a strange natural comet from another star system? Or could it represent something far more unusual? Let me know your thoughts in the comments below. And if you enjoyed this deep exploration into one of the strangest objects ever observed in our solar system, don't forget to like the video, subscribe to the channel, and share it with others who are fascinated by the mysteries of space.